Welcome to ECE 3270, Lecture 6. Today we're going to be talking about HMIs. Specifically, we're going to be talking about how HMIs communicate with the PLC and what the purpose in general of an HMI is when it's integrated into a machine with the PLC. And we'll be discussing some of the best practices when you are developing an HMI application. Then we're going to take a shift and we're going to do a practical demonstration of how to develop an HMI application. But before we do any of that, let's do a quick industry connection segment. Here in this video, we're going to see a machine that's still very much in the development stages, but it demonstrates a couple of cool things that we'll see in other industry connection videos. Number one, it's going to explicitly show the use of an HMI, and it's also going to show an application of linear servos or linear stepper motors used as a precise positioning system. So let's just take a quick look. So this is a barcode reader. So here, let's roll that back. Okay, so this is the e-stop. This is the power on button. This video is a bit blurry, and this is a key that was used for some certain specific things on this application. But here is the HMI. So this HMI is how the operator is to interface with this machine. If they want it to do something, if they want to change something about the machine, the HMI is where they would go to do that. And what we're about to see is the operator is going to put the machine into automatic mode. So the operator was attempting to scan in a barcode. The problem was the machine wasn't running. So just like we've seen in some of the labs, we did the sawmill. So when the operator pressed start on the sawmill, it would continue to run until the operator pressed stop. So in this situation, no one's told the machine to start running. And so we'll see the operator reach over and press the auto button on the HMI. So here you can see they're about to press this button labeled auto, and this means the machine is at a state where you can go into auto mode. So we'll continue the video from here and see a linear actuator in motion after the machine goes into auto mode and we complete the barcode scan. So press the button, turn green, scan the barcode, press the go button, and here goes the linear actuator. That right there, that movement. So that movement that you just saw where this slide went from here to here was performed by this linear actuator. So this box that you see with the shiny stripe on top, so that actually continues all the way over to here, and that has what's called a ball screw inside. And that screw turns and moves this sled back and forth, and that screw is driven by a linear servo, or in this particular situation, a linear stepper motor. And so we've talked about previously using pneumatic cylinders to provide motion in automated machinery, and that's most of motion in automated machinery. However, sometimes you need to be able to do precise positioning, and you don't just need to move something back and forth. You need to go from a precise location to another precise location, and maybe many precise locations in between those. And in those sort of applications, you'll see linear servos used, or linear stepper motors. So this is one of those applications. What we're doing is we're positioning various different work pieces. So this would be a work piece, this would be a work piece, underneath a press, And we've talked about presses before, and then once everything's positioned and lined up correctly using these linear servos, the press is going to mash it all together. So let's finish the video and see why we needed such precise positioning. So a big press comes down and mashes that on. And then linear servo moves it back across. And there we have it. So a couple of things we saw in this video. Number one, we saw that the HMI was used to provide input to the machine and to be able to view the state of the machine. Number two, we saw linear servos used for precise positioning of work pieces. And in this particular instance, the reason we needed such precise positioning was because we were going to take a really powerful press and ram it down on top of it. So we need to make sure it's in the right spot at the right time. So that video provides us a nice segue into sort of a basic question we need to understand about HMIs. What are they for? So HMIs, what they are for. An HMI literally stands for human machine interface. HMI. So in the video we saw that we could change the mode of the machine, view the mode of the machine, and there was actually a host of other things that you could do through that HMI. In actuality, that HMI is the way to change or view anything there is about the operation of that machine. So it is literally the interface between the human and the machine. That's how the human tells the machine what the human wants, and it's how the machine tells the human the current state of affairs. So quite literally, it is the human-machine interface. And that's not limited. So anything that the human, we usually refer to the human in those sort of situations as the operator, anything the operator might need to know needs to be viewable in the HMI. Anything the operator might need to be able to change needs to be editable in the HMI. So it's the one-stop shop for control and status of the machine. So that's the one-stop shop. For all control and status. So that's why we have HMIs paired with PLCs, because the PLC contains the program that is written to carry out whatever operations that we have decided we need to carry out. But the HMI is what allows you to combine that powerful automation with a human element. So it's the go-between. So if that's what they're for, how do they work? How does an HMI have a button on the screen that affects something inside the PLC? HMIs have utilized a lot of different technology over time, but in general, they all operate via what's called field bus. Different field buses have been used, like I said, but even today, when we're talking about a network involving a PLC, there's a more specific term that gets applied, and it's field bus. Specifically, the field bus that Alan Bradley uses is called Ethernet. So Ethernet IP, actually, not just Ethernet. So Alan Bradley's field bus is Ethernet IP. And when we go in and set the communication setup for the HMI, like you have to do each time that you download to the HMI, right? What you're actually doing is you're pointing the HMI at the PLC, and that allows the HMI to utilize this Ethernet IP network that is attached to the PLC and to use that address to go in and modify or read any of the tags in the PLC that have been set to allow remote access. So using this field bus, the HMI has some button. Let's call it start. Okay? And inside this PLC over here, usually there's cards in a rack beside the PLC, so this is our PLC. PLC, HMI. Okay, so inside this PLC, there's some tag. Tag name, start, and it is a data type Boolean. And let's say its current value is false. Okay? Well, there is an Ethernet IP network that connects the HMI and the PLC. So when someone presses this start button, the HMI sends a signal to the PLC to change the tag value stored in the tag start to true. Then, when the person releases the start button, the HMI sends another signal to the PLC to change the value of the start tag back to false. That's called a momentary push button. So the tag that this button is connected to is set to true while the button is pressed. But as soon as the person or whatever's pushing the button stops pressing the button, then the value false is sent to that tag. So we press start, and the tag that's associated with it in the PLC, in this case the tag's name is start, becomes true. Then you release the start button, and the tag in the PLC becomes false again. And this all happens via the Ethernet IP network. Now there's an attribute for each tag in the PLC where it says externally accessible, and that has to be set. So each tag can be set so that you can't access it from an HMI or so that you can access it from an HMI. And that's for security purposes. Maybe there's some sensitive things in the PLC that you don't want someone to be able to change via an HMI screen. Well, then you can set it so that there's no external access allowed for those tags. But there are certain things that you definitely want to be able to display on the HMI and certain things you want to be able to edit on the HMI. And those you need to enable external access. Now this discussion that we've had right here revolved around the momentary push button. But in the coming lab and in general, there are 5 objects that you need to be aware of and ready to be able to use. Number 1 is the momentary push button. It's one of the most useful and common objects that you can use on an HMI. But the other 4 would be numeric display, numeric entry, text box, and the multi-state indicator. Now I didn't write those down, and I'm not going to show an example right here because as we work through a practical example at the end of the lecture, we'll see each of those. And you'll become even more familiar with those in the coming labs. So now let's turn our attention towards some best practices for when you're developing HMI applications. First of all, it's not best to always have to reinvent the wheel. So if you're developing an application that has similarities to an application you've developed previously, you're best to start off with sort of a starter file rather than having to go back to square zero every time, because there's lots of settings and lots of little things that you have to remember to do when you're creating a new HMI application. So in general, it's best to have some sort of starter application where all that's set and you always work from there as your square zero. In this class, we'll always provide you with your HMI starter file, and it'll typically be named lab whatever. So if you're expected in lab 7 to create an HMI page, then you will be furnished an HMI application as a starter file. But in general, that's a good practice. So even in industry or in companies that do this professionally, you're better off using a starter file than starting from scratch. You're just likely to forget less. So use a starter file. Next, when you're creating your application, you don't want to have too many clicks necessary to navigate from point A to point B. So if you notice in the labs, so far there's been a banner at the top of the screen. So on the HMI screen, it might look something like this. Up here, there's a banner, and there's a tab for for the welcome screen. There's a tab for lab 1, lab 2, part 1 of lab 1, part 2 of lab 2, so forth. And this allows you to be able to get from any particular part of the lab to any other particular part of the lab with a single click. So minimizing the number of clicks necessary to get from any page to any other page is sort of a guiding principle when you design HMIs. So minimize the necessary clicks. The reason to minimize the necessary clicks is because if you don't, then it can easily become cumbersome, and it can become almost like a paged setup where you're having to, use a button on the right to say go page right, use a button on the left to say go page left, and you're scrolling through hundreds of pages to find the one that you want. That's a very bad setup. It's much better to take a modern UI approach, so user interface approach. So when you're designing these HMI applications, what you should be thinking about and what you should be using as sort of inspiration is things you see in the Android and Apple interface. So they have perfected, at least so far as the industry has developed, Android and Apple have perfected user interface design. And Windows is coming up in the world as well, in my opinion. But Android and Apple have always been at the cutting edge of developing usable and functional interfaces. So emulate what you see on your phone. The design and layout of the page structure, the design and layout of the navigation structure. That's what you should be seeking to emulate when you create an HMI application. Now, that's all well and good and helpful for when you're creating a large-scale HMI system, but in this class, you're not going to really have time to do that. So instead, you're going to spend your time creating HMI pages, a single page. And when you do that, there's a couple of things you want to keep in mind. Number one, you want the page to be self-explanatory. So it shouldn't be true that they need an instruction manual to be able to use the page you have created on the HMI. So your page or screen, some people call it a page, some people call it a screen, should be, or even a display. So you could call it a page, you could call it a screen, you could call it a display, whatever you want to call it. A single HMI screen, page, or display should be self-explanatory. You should not need to follow the TA or the instructor to your HMI and tell them how to use what you have made. It should be obvious. And you can make it obvious by using well-named and appropriately described buttons and fields. So we're just going to say good naming / comments. So if it's not self-explanatory, then that means you didn't do this well. And something that goes along with that is good layout. So you might have everything named well, but you might have some sort of wonky, weird system where you have put, here's your HMI screen, and over here you put a text box that says press button, and your button's down here in the left-hand corner, or the right-hand corner. Well, that's a very silly layout. Why would you do that? That it seems like this statement press button is dissociated with this button. So it's not self-explanatory anymore because you have a bad layout. So take care to have a layout that is intuitive. Take care to have good naming and good comments so that your HMI display, in Allen Bradley is the correct term, but in other systems you'll hear them called page or screen. But in here, that your display is self-explanatory. Finally, you need to develop HMI displays that are professional looking. So let's say that part of the lab is to design an HMI interface for a small crane. Well, if you do not take a professional approach to that assignment, then your HMI display may or may not reflect that. Okay, so a professional HMI display in that situation, there's a lot of different ways that you could go about it, but number one, it should have all the necessary controls. It should give you all the necessary information, but it should go above that. So the expectation, here's the guiding principle. There's an expectation, and there's also requirements, okay? So the requirement is that if you're going to make a page to operate a crane, it should display all the necessary information about the crane and give you all the necessary control. That should make sense. That's the requirement. So to be professional, you must meet requirements. But that's not enough. There's a step further. Number 2, exceed expectations. The requirement is that all the necessary controls and all the necessary status information be present on this crane control page. That's the requirement. You have to meet that. But then there's also just an expectation that it'll look nice. Exceed that expectation. Go above and beyond to make this look great. Make it something that you're proud of. This is the recipe for success in most professional environments. Meet requirements and then exceed the expectations. So in this practical demonstration, what I'm going to do is I'm going to show how we could have a button to turn on a Boolean tag in the PLC, and that Boolean tag is going to be connected to a timer. And that timer is a T-on timer, which is a timer on delay, right? So it's used to answer the question, has this tag been on long enough, or has this condition existed long enough? So there's going to be a tag connected to a T-on timer, And on the HMI, I need a button to be able to turn the tag on. I need a numeric display to show the current elapsed time. I need a multi-state indicator to tell me whether or not the timer has completed. I'll have a text box to show the instructions for how to use that page and give some information. And lastly, I'll have a numeric entry where I can enter the target time, so the preset for the timer. So before we jump to the actual coding or design of this application, let's just quickly draw out what this should look like. So here's our screen, rough sketch of the screen. Let's say we want to put a momentary push button here called Start. And when this button, this momentary push button, has put the value 1 into start, we will say release to stop. So the alternate text on this push button will be release to stop. And you'll understand what I mean by alternate text when we begin to design this in FactoryTalk View Studio. So we have our push button. We need a place to display the elapsed time. And what we're going to do is we're going to put a text box and say elapsed time. And this will be a numeric display field. And then we're going to have a multi-state indicator that will be on to show that the timer has completed. Then we're also going to have a text, or not a text entry, but a numeric entry box where we can decide how much time we want to set the preset to. So we'll have a text box, first of all, that says preset time. And then just so that everyone understands, in both of these text boxes, we're going to put in parentheses MSEC to stand for millisecond. MSEC. And then below here we'll have our numeric entry. So that's how this will work. So when someone uses this page, they'll press this button and this time will begin to accumulate. And then when this time is greater than or equal to this time, this completed light will come on. And this will demonstrate, what we'll do is at the bottom of this page, we're going to put another text box and say, page demonstrates T on functionality. So that way it's understood exactly what the goal of this page is, it's understood how to use it, and they have everything they need. So understand, that's the absolute requirement. This page has to work. You have control to be able to start the timer. You have control to be able to change the preset time on the timer. And you can see the elapsed time, and you can see if the timer is completed. So you have everything you need to view the status and to change the status. Moreover, it's laid out nicely, I think. So you're working from left to right here. Hold the button on the left, see the time accumulate, wait for the light to come on. You see, so it is intuitive. But then below that workflow, we have a place to be able to adjust the preset time. And finally, we have a statement about what the page does. So this is what we're going to now create in FactoryTalk View Studio. Okay, So here we're going to actually create the HMI that we discussed just a moment ago. So first, notice we have our logic already written in the PLC, and we have our tags created. And to be able to use them in the HMI, we have to have the external access set to at least read if we want to be able to view it. But if we want to be able to change it via the HMI, we have to have it set to read and write. So we have all of these tags: elapsed time, preset setting, timer complete, and start timer, all set so that we can read and write them from the PLC, or from the HMI, sorry. So now it is time to actually make the HMI. So here's the HMI software that you have become familiar with. We've already at this point gone through and set up the communications. You know how to do that. So now what we're really interested in is editing the HMI and connecting the objects that we use in this HMI to the tags in the PLC. So first of all, as I said, in the Rockwell, which is the umbrella company for Factory Talk and Allen Bradley, in the Rockwell world, we call screens displays. And different PLC companies, different HMI companies name this differently. Some call them screens, some call them pages, some call them displays. So here in Factory Talk View Studio, they're called displays. So there should be a main display for Lab 7 that's very familiar to or similar to the main display that you see in every lab that you've done so far. This main page is the page that will come up automatically when the application begins to run on the HMI. So if you're going to have any other pages, it's important that you have a way to navigate to those other pages, or other displays, I should say. I'm used to calling them pages, so you'll hear me slip into that. Anyway, you need some way of navigating across the various displays that you may create. So in here we have a banner at the top of the screen that allows you to navigate to the various parts of the lab. So I'm not going to explain that because that's a little bit out of scope and you don't need to understand that at this point. But there's a way to include a button to be able to do a display change. But that's already been done for you. So we have 4 display pages that you will use in Lab 7, and it's really Lab 7 and Lab 8. It's a 2-part. So in Part 1, you see a blank HMI page that just directs you to delete this text box and customize the screen to accomplish whatever the required functionality is for this particular lab. So this is the generic lab starter file that I alluded to previously in the lecture. So let's edit this screen to make it like what we drew in the lecture. So first of all, to do that, we need to include a momentary push button. And we want to include the momentary push button and connect it to our start timer Boolean tag. So let's go ahead and do that. Let's say objects, push button, momentary. Now notice there's others, but don't worry about those at this point. We are going to be using the momentary, primarily all the way through this class. So momentary push button. So now it didn't appear on the screen, but what did happen is my cursor can now draw a momentary push button. So now I have a push button. And immediately the properties window opens. The most important thing that you're going to do in this properties window is set the connections for this button so that it will actually talk to the PLC tag that we have created. To do that, we click here on the ellipse underneath the tag column beside value, because we want to connect the value of this momentary push button to some tag in the PLC. So then here this tag browser pops up, and we can actually browse and see tags that are available in the PLC. So we highlight PLC, we open it up further, then we highlight online and open that up further, and we highlight our main program because I put them in the local tags in the main program. And now we see elapsed time, preset setting, start timer, and timer complete, which are the tags that I created. But it's possible that you may not see this, but you might have done everything correctly, in which case you would click refresh all folders to verify that maybe just the software hasn't gone out and read the latest available tags in a while. So we want to connect our momentary push button to the start timer tag, and it will populate. So if you understood this syntax, you could just directly type this in, but it's easier to use the browser because the syntax is a bit wonky. So we're not going to connect it to an indicator, but if we wanted to have the state of the button driven off of another tag, we could do that by connecting it to an indicator. And notice the direction of this arrow. The arrow coming from the tag means that it's going to affect the button. So it's going to change something about the button. This is bidirectional. So the value in the tag will affect the button, but the value in the button will affect the tag. Now, after you're done in connections, we need to go over to states. There's a state 0 and a state 1. So a state when the value of the tag associated with the button is 0, and a state when the value of the tag associated with the button is 1. So when it's 0, we said we want it to say start. And when it is 1, we said we wanted our alternate text to be release to stop. Good. So let's also adjust these colors just a bit. So let's do caption color, and we'll use the tech gold. And for, no. So for state 0, we'll use the tech gold as the caption color. And we'll use the back color we'll have the back color be purple. And then in state 1, we'll swap it. So we'll say the back color is gold in state 1 and purple. Perfect. So now we have the text for the button that tells what it does. We have the alternate text for when the button is pressed, and we've set the colors so that it'll look nice. Let's apply and look and see. Uh-oh, we did something wrong. So notice here, I'm still drawing push buttons according to my cursor. So we can come up here and click the select arrow to be able to double click this and bring the properties window back up. Let's check out what's going on in the states. Oh, the caption back color may be purple, but notice the caption color is set to white. So my mistake. Same thing here. Caption color is still white, so let's adjust that. Okay, apply, check it. Yep, there we go. Looks good. So we have a button that says start, and then when we press it, it says release to stop. So now we have created a momentary push button and associated it with a tag and adjusted the look of the button. Now let's insert a text field. So we could go through objects and we could go through, let's see, numeric and string display to display a string that is stored in the PLC if we were keeping a value inside of a string we wanted to display it. That'd be one way to display text. But that's not what we want to do. We don't want to have text that we can change. We want to have text that is the same all the time. So the easiest way to be able to do that is to insert a text box. So the A in most environments is a representative for a way to insert text. So let's use that, and then we can enter the text directly. And so what we want to say is elapsed time MSEC. And we're going to have the forecolor of this be gold. So now we have our elapsed time, and now we need to have a numeric display. So objects, numeric and string, and this time we do want to be able to display the value that is actually inside the PLC. So with this text, right, it didn't come from some value stored in the PLC. We just wanted to be able to type it in to tell whoever's using this HMI something about what's going on. But this time we actually want to display the contents of a numeric tag that is stored in the PLC. So we're going to go in here to Objects, Numeric and String, Numeric Display. Now notice I can draw a numeric display. Okay. Let's do the same deal. Let's change the back color. Let's go with gold for the back color, and that'll work. The next thing, as with the push button that we have to do, is the connections. So the most important thing that you're going to change in here is the connections. If you don't get this right, then it's not going to work at all. Notice the arrow. So the arrow doesn't go from the display field to the tag. It goes only from the tag to the display field. The reason there is because we are not going to be able to enter a value into this. We're only going to be able to read the value from the PLC. So let's find the tag we want. So this is the elapsed time. So we go to the tag browser and choose elapsed time. And we apply. But I don't like that the text is still white. For color, change that to purple. Apply, there we go. Okay, let's change back to our selection tool. So now we have our display for the amount of time that has elapsed. Now we need our multi-state indicator to tell if the timer has completed, and a text box to tell what it does. So let's above this, let's put a text box and say timer completed. And we'll say the forecolor will be again tech gold. Apply, timer completed, good. Change back to selection tool. Okay, now we need a multi-state indicator to be able to show whether or not the value is true or false. So let's go down to indicator, multi-state. We're connecting this multi-state indicator to a Boolean tag to display whether or not the tag is true or false. So again, you select that tool, and now I'm able to draw a multi-state indicator. So we're going to adjust this a bit. So first of all, let's change the shape to be a circle. And let's say the number of states should be 2. And we'll leave it at trigger type value. We'll say the border width should be a little smaller. Let's go with 4. Now, let's go ahead and change the connections. So let's apply that, see what it looks like. Okay. Let's go to the connections. And notice again the direction of the arrow. The value in the PLC tag is going to affect the indicator, but the indicator is not going to affect the tag. So we're reading the value from the PLC. So we will use timer complete to drive the state of this indicator. So let's go back to the states. Let's say state 0 should have a back color of purple. And let's say that the caption back color should be gold. Wait, this is state 0. I don't like that. Let's keep the back color purple, but we'll do caption back color. So this is when it's off. State 0 is when the indicator is off. So instead of having it be gold when it's off, let's have it be gray. It's just grayed out. And then state 1, we will have back color be gold. Sorry, purple I meant to say. And we'll have the caption back color be gold. So purple and gold when it's on, purple and gray when it's off. Let's apply that. It disappears. So now we have our indicator. I don't like that it disappeared. Let's change that. So let's say that the border doesn't use the back color. And now we can see where it's at. And you can play with colors to make it look however you want. And we'll shrink this down a bit so that it looks more like a light coming on. Okay, and let's adjust the spacing so that it looks a little better. There we go. Now, we need a way to enter the preset time. So let's create a text box here and say, enter the desired preset time. For color gold, okay. Excellent. So now we need to be able to enter the preset time. So let's create a object to deal with a number, and we want to be able to input the number. So we have selected the numeric input enable tool. Let's draw it. Okay. Back color. Let's go with gold this time. Raised border. Back style solid. Rectangle. All that good. All right. Now, the most important thing, connections. The only connection that you really need to have here is the value. There's lots of options and lots of things that you can configure about a numeric input enable. We're not going to go into all of that. What we want to be able to do is input a number. To be able to just simply input a number, we need to associate a tag with the value descriptor, the value property of this numeric input enable object. So beside value, we click the tag ellipse, and we are going to select the tag that we want to change when someone uses this numeric input, and that is the preset setting. So let's look and see if there's anything else we want to adjust, and you can look through here all you want. So the minimum value will be 0, the maximum value is some very high number because it knows it's associated with a dent. It's going to be a keypad pop-up. There's other options. You could attempt to do a scratch pad, but keypad seems to make the most sense. And the label. We could have a label here if we so chose. I don't think that we should. I think rather allow the user to read the above text, but let's actually add just something that says preset setting. And we'll say MSEC. So this, coupled with the text above, will make everything clear. Caption color, purple. Apply. Okay, so they will click this and type in whatever preset value they want to have for the preset on the timer. The last thing we said we were going to do was create a statement at the bottom that said, this page demonstrates the functionality of the T on timer. And let's change the back color, the forecolor, to gold. Move it over. Okay. Now let's test this and see if it works. So when you're creating an HMI page, before you actually download it to the HMI, which takes a moment, you can easily test it by pushing this play button. So we see the 0 is in the elapsed time. We can click the preset setting and type in whatever we want. Let's say 500 milliseconds for the preset. Let's go over to our PLC and see if we have 500 in the preset. We do. Perfect. So that works. Let's click and hold start. Release the stop. Oh, and we see the elapsed time. Perfect. And we see the timer go from filled with blue to being purple in the interior, which means that it came on. I don't like how that looks though. Let's adjust that. So let's change the state 1 to having a back color of gold. State 0, yeah, we'll leave that like that. We'll say state 0 has a back color of gray. Apply. Okay, so now let's test this out. So our button is gray. And after being held for 500 milliseconds, it goes to gold, which means the timer has completed. So let's change the preset time to, let's say, 1500 milliseconds, so a second and a half. And then let's hold this for 1500 milliseconds. We see the time going up. And then when we release, we'll see the elapsed time go to 0 because if you remember, the T on resets whenever the enable goes off, and it does. So this demonstrates the T on timer functionality, and it meets the requirement that we laid out in the lecture. I wouldn't quite say that this exceeds my expectations. I think it has nice coloring, so maybe that exceeds expectations a little bit, but I would say this is the minimum I would really be happy with. I want to see you guys put effort into the displays that you make. So this has demonstrated the momentary push button, text box, numeric display, multi-state indicator, and numeric input objects.